Hello everyone, welcome back to another AP Physics problem walkthrough. Today we're going to be going over question 7 in the MIT AP Physics 1 workbook. So without further ado, let's go into the question. A projectile is fired with initial velocity v initial at an angle theta initial with the horizontal and follow the trajectory shown above. Unfortunately guys, I just want to let you know that we do not have a graph above, but we'll be able to still solve the problem. Which of the following pairs of graphs best represents the vertical component of the velocity and acceleration v and a, respectively, of the projectile as a function of time? So the question is asking us a projectile that is fired, fired at an angle theta initial with velocity initial. And it's asking us what is the vertical, because this is a key part, what is the vertical components of the velocity? And knowing that, we can go ahead and draw our parabola shape, since we know this is shot at an angle, so it's going to make a shape of a parabola. And we know that as this goes on, the velocity in the horizontal will be a constant velocity going this way, constant velocity going this way, constant velocity going this way. But what does change is the velocity in the vertical position due to the gravity acting on it. So since we know that, one important key fact of a projectile motion problem is that right here at the vertex of the parabola, the velocity here is equal to 0, but the acceleration is equal to 9.8 meters per second meters per second squared, because the gravity is constant throughout the whole motion. Since gravity is 9.8 on Earth, it's going to be constant the whole time. So with that knowledge of the gravity being constant, we can go ahead and look at these answer choices and first cross that out, since we can see that all these accelerations are pretty different. So with that being said, let's look at choice A. Choice A says that the acceleration is going to decrease over time. And we just said that the acceleration is constant, so it decreasing would just make it wrong. So we can cross out A. B has the acceleration increasing. And we know that the acceleration has to be constant. So an increasing acceleration just proves that it's wrong also. So I can cross out choice B. Choice C has the acceleration also, that is not the acceleration, has acceleration constant. So that is true, it is constant, so we can keep that. And then choice D also has the acceleration as constant, so that's another choice. Now, the main difference between choice C and choice D is what value is the acceleration constant at. So as we can see, in choice C, the acceleration is constant 0. But over here, we said that the value is 9.8 meters per second squared. So how could it be a constant acceleration of 0? So already I'm thinking that choice C cannot work. But if we go to choice D shows that we have an actual value down here. And that value, to me, looks like that it should be around 10, so 9.8 meters per second squared. And you might be wondering, but this is under the x-axis, meaning that this is negative because this is positive. And you are right. Because acceleration is a vector, it has both magnitude, so the 9.8 meters per second squared, and direction. And since the object is always getting pushed down by gravity, anywhere it is, always getting pushed down by gravity, the sign would be negative, causing the acceleration to be negative 9.8 meters per second, which is also equal to g. And just using that knowledge, we were able to get answer choice D as the correct answer. I hope you guys enjoyed the video. Thank you for watching, and please comment down any questions that you guys would like me to go over with, or any topics. And as always, I would appreciate any feedback that you guys have for me. But I hope you guys have a good day and continue your prep.